Hello, in this video I'll be talking about finding the mean, or also known as the average. The mean of a set of data is the sum of the data divided by the number of data items. Rather than adding everything and dividing by the number of items, you can also adjust all of the values so that the values are the same. So let me show you an example to show you what I mean. On 4 days it rained 2 inches, 4 inches, 5 inches, and 1 inch. And so I have a number of blocks here equal to the number of inches it rained on each day. So here's the 2, the 4, the 5, and the 1. So one way we can do this is adjust it so that all of the columns or all the days have the same amount of blocks here. So we can see that each column has 3 blocks, and so we know that the mean is equal to 3. Okay, let me put that back the way it was to show you that it will also work the traditional or standard way, which is the sum, which means addition of all the data divided by the number of data items. So there's a 2, a 4, a 5, and a 1. So if you sum all of those up, 2 plus 4 plus 5 plus 1, you get 6, 11, 12. And then you divide by the number of data items. So 12 divided by 4 data items will give you 3. And that's inches of rain, is the average or the mean, which is the same answer we got when we rearranged the blocks here. Let's try another example. You measure the temperature outside each day during the week. The temperatures are 95 degrees, 96 degrees, 103 degrees, 99 degrees, and 96 degrees. Find the mean temperature. Okay. So the first thing we need to do is add up or sum all of these numbers. It would be tedious to make a model here because you'd have to have quite a lot of blocks, but you could try it out. So let me get a different color here. There we go. Alright, so we have 95, we have 96, we have 103, we have 99, and 96. Now all these numbers are very close to 100, so I could say, well, 500 minus 5 is 495, minus 4 is 491, 494, 493, I think it should be around 489. Let's see if that's right. So 11, 14, 23, 29. 11, 20, 29, 38, and 489. I can't even remember if that was my guess, but that sounds reasonable since this should be close to 500, so 489. And now we're going to divide by the number of data items, which was 1, 2, 3, 4, 5. So 5 does not go into 4, goes into 48 9 times. And then we get 39, which goes in 7 times. And then now that I have to add a 0, I'm going to put the decimal right into the answer here, and 5 goes into 48 times, and I know that that's even, so we're done. So the answer is equal to 97.8 degrees. Now, one thing to keep in mind when you're doing a problem like this is to double check that you have all the pieces of info written down. So we have 1, 2, 3, 4, 5. An easy way to do that is just count here how many you have. 1, 2, 3, 4, 5. Make sure that matches up with the divisor there. When you get this answer of 97.8, you should see if it kind of is somewhere in the middle of these numbers. If it's not, you probably made a calculation mistake. So it's bigger than that, a little bigger than that, smaller, smaller, a little bigger. So this is definitely a reasonable answer. So we can be pretty confident. Also, notice that there's a decimal here, so it would have been pretty hard to model this situation. So not only would it have been slightly difficult to just have that many squares, but it would also have been difficult to model it with a decimal as well. All right, let's try another. Before we begin, we have a definition here. An outlier is a data item that is much greater or less than the other data items. If a data set has an outlier, then the mean may not describe the data very well. Okay, so here we have some quiz scores, and we're going to try to figure out the mean or the average. So we have an 81, an 89, 75. So let's start writing these down. 81, 89, 75, 77, 81, 42. This is a lot of numbers to be adding up. Calculator probably would be helpful in this situation. Another thing you could do is add up each column first, just so you're dealing with smaller numbers, and then add up the three numbers. So let's see what happens when we go for it all at once here. 9, 10, 15, 22, 23, 24, 25, 6, 7, 28, 29, 30, 31, 32, 34, 35. Carry the 3. Here we have 11, 19, 26, 33, 41, 45, 54, 62, 70. Okay, so I think that's 705. Let's see if that makes sense. There's 9 data, and they're not all 100, so they're all about 10 to 20 less than 100. So it would be 900 minus about almost 200. Okay, that makes sense. So 705, I'll go with that. And there are, like I said, 1, 2, 3, 9 pieces of data, so we're going to divide by 9. 9 doesn't go into 7, goes into 70 7 times. And then we have 75. Let's see, 72, so that goes in 8 times. And then we have a 3, so we're going to have to keep going. Remember to put that decimal right into the answer once you have to use it. That goes in 3 times. And it looks like we'll just have a repeating 3 from now on. So it's approximately 78.3 repeating for the average quiz score. Okay. Now keep in mind, part of this problem is that we're talking about an outlier, and so we're thinking maybe 78.3 doesn't describe the data well because there's this 42 that's bringing down the scores. So notice 78.3, it's below that, it's a little above that, below, 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 a little above, a lot above, and below. So it's below most of the actual data. If you were talking grade-wise, we got a B minus, C plus, A minus, B plus, B minus, B plus, C, F, B minus. So most of those are B minus or above, but yet our average says C plus. So this outlier may be affecting it. Let's check it out. Let's try to pretend this outlier wasn't there and take away 42 from this. So 705 minus 42 is going to be, what is that, a 10? So 6, so 663. And then we're going to do some division here. So 663 divided by 8. That goes in 8 times into 64. So we have 23. It's almost 3, so it's 2. 16. 7, so we're going to have a decimal here. 8 goes into 70. Let's see. 64, so 8. So we're looking at, I'm just going to stop here just because I only have to get to the tenths to compare to this. So we're looking at a difference. Let me put it in different colors here. So the initial one was 78.3 repeating, and then without the outlier we have an 82.8, which raises it about 4.5 points. Okay, so because of that outlier, it brought down the average quite a bit. And so in this instance, you might consider that the outlier is changing the average too much to really show what's going on with the data, so you would consider doing another version without the outlier. All right, thanks for watching.